let's get going then. Okay. Hey, here are my papers. Well, seems that I have lost all the papers which I had. Where did I leave them? Okay, now guys, let's get started. And today, essentially, we are doing some the final touch on the concepts of a trigonometric functions before we move on to the some of the basic concepts in the trigonometric identities from next Monday. From next Monday, we are going to apply more of the things which we have learned for more practical purposes. But not today. Yesterday, if you remember, we talked about, I should say, the trigonometry of a right triangle, which all the homework which you're going to have for this weekend is focused on that concepts only, not for today. Your weekend, you're going to have a comprehensive, I should say, homework assignment, just focusing on the things which you learned yesterday. This one, you get the homework of that a little bit more later then. Okay. And now, in order to do that, we are just going to go to the case that we are going to step away from a right triangle, because yesterday what we did was that we defined 6 trigonometric ratio for, I should say, for a right triangle. And essentially we saw that how can we just solve a right triangle? Because the purpose of the yesterday lesson was that when you have a right triangle, you should be able, with only one length and what angle, decide about the other, I should say, angles and the lengths. I'm just going to give you one example before we move on, and then we are fine with it. Then we catch up with more new stuff then. About, I'm going to give you, I think we had an example yesterday. We saw an example yesterday, huh? I think we didn't just leave anything behind from yesterday. And that's a good thing that we can just start from right now. Okay. Guys, before, when we talked about, let me get also my tools. Okay, previously what we did, before we move on to the right triangles, we saw that if we have a Cartesian coordinates like this, which is going to be the x, and this is going to be the y. If you have the Cartesian coordinates, I can just come here to just write a circle, which we call that the unit circle. And we saw that if I come here to define an angle, I say that, okay, it's going to be, for example, this one is going to be my fixed arm of the angle. And this one, for example, I'm just going to go here to pick up one point on the circumference of this unit circle. And I call that angle, let's say, I call that, for example, the angle, I call that alpha. What we did before, so far, before we move on to the concepts of the right triangle yesterday, we saw that when we define a trigonometric ratio in this setup, I told you that you only look for the points which they are essentially like point A, which they are on the circumference of this circle. And when they are on the circumference of the circle, the point just rotates around the circle. And that's why, and that's where we define the concepts of the periodic behavior. And we saw that periodic behavior when we just did the plotting of the sine and cosine functions or any trigonometric function. We saw that there is a repeated pattern because the pattern comes from this one. Then the point starts from this, which is represented by one point on the plot of the function. The point can come back to the same spot. And that's why you see the point is being repeated all over the place. And the function behaves periodically. And we saw that before, that when you're on the circumference of the circle, because of the symmetry which the circle introduces on the geometry of the problem, we can always come here to find at least 3 other points which they are going to behave exactly like the point A. And we found them by using the symmetry, which is essentially introduced by, I should say, by the point, by the circle. And we saw that the values of the x and y, which point A gets, it's going to be only limited that when A is rotating around that circle. For example, when A was the coordinates x and y, for the other points, we were able to find the same coordinates. For example, for this one, I was able to write what? This point is going to be B. What is the coordinate of this point? If A is x and y.
Minus x and y.
That's right. Becomes minus x and y. And how about this point, if I call it point C?
Minus x and minus 1, y.
That's so true. And how about this point, if I call it point D?
X minus y.
That's so true. Then you saw that if the Cartesian coordinates pinpoints and localizes the point which is rotating only on the circle, you can get at least 3 other points which we call that the twin brothers of point A, because they were behaving exactly like the point A was behaving. And you pinpoint, for example, you get to know about the point B, it seems as if you know about point C, point D, and point A. You get to know about point D, it means that you know whatever you need about point A. That was a basic idea we talked. And also, before, you notice that because of the circle, and also we have some kind of, I should say, more interesting stuff. The Cartesian coordinates gives these generalized coordinates of x and y over there, but for these Cartesian coordinates, and because of the circle, we get the angles that we can get from point A to point B without knowing the coordinates of the x and y. For example, if this point A segments the angle of the alpha there, how much is the angle from point, this one, I call it point, let's say, I call it point R as a reference, point O the reference. What is the angle ROB?
Pi minus alpha.
That's right, becomes pi minus alpha. Fantastic. And let me change my color. I go to this point again also, to point C, because point C is a twin brother of point A. Then what is the angle of ROC?
Pi plus alpha.
That's right, becomes pi plus alpha. Then you know that if you do not even know these generalized coordinates of x and y, and you only talk about the alpha, the angle which you segmented that on the unit circle, you can move around, find the other twin brothers, which is going to behave exactly like the A. And eventually, for the very last angle, which is going to be this, from the origin goes to here, and the angle which it rotates, it's going to be this. How much is that going to be?
2 pi minus alpha.
That's right, 2 pi minus alpha. We use this kind of identity, not identities, this kind of information to move around in the Cartesian coordinate, in the unit circle, starting from one point, find the other points. For example, we had that point, we were able always to come back to the first Cartesian, the first quadrant. Or for example, you were given 1 point, if you notice that on your homework, you were given 1 point, for example, at the third quadrant, then you were able to move back to the first quadrant and express that point in terms of the reference angles, which it was, let's say, for example, 45, 30, and 60 degrees. And the thing which we did, I just given an example right now there. It's a kind of a review. For example, imagine the thing that we talked about that before. I'm going to say to you that, for example, you look at the behavior. I'm going to give you one, for example, one angle, and the angle is going to be, let's say, what the angle can be. For example, let me see the angle which we can think of. For example, imagine 11 pi over 12. That's an angle. And I'm going to ask you, please, guys, I'm giving you this angle. Please understand how this function sine of that point is going to be evaluated. Find an exact value of this. What to do with it. Because 11 pi divided by 12, if you convert that to the degrees, you know that from here you are 0, then you get pi over 2, you get 2 pi here, you get 3 pi over 2, then you see that 11 pi divided by 12, which quadrant is that? 1, 2, 3, or 4? Which quadrant is that going to be then? You multiply 180, you replace pi by 180 and multiply that by 11 and you divide it by 12. How much do you get? Guys, please do that on the calculator. Let me do that here on my side. Let me do that. How much do you get? 11
160.
times, how much?
165.
65. I got 165. You got the same thing?
Yes.
You get 165. 165. Okay, how can we just write it in terms of the angles that we know? Can I write it as, let's say, for example, 90 plus, not 90. Let me see, how can you write it? 45 plus 11 pi divided by 12. Oh, okay. Can I write it? It becomes 165. 165, guys. Can I write it like that? For example, write it as 180. Can I write 165 equals to as, let's say, for example, 45 plus 120. Can I do that? Guys,
Yes.
please look at this example. There's so much things to remember from the things which we have done in the past. The question which I raised here for you guys is that what is gonna be the sign of this animal which looks not familiar? Because when I tell you, for example, the sign of pi over 3, which is, let's say, 60 degrees, you readily know what is that, because that's a reference angles which we have to memorize them, because we learn them by constructing a special triangles. But for this one, 11 pi divided by 12, it becomes 165. And 165, which quadrant is that going to be?
2.
2, that's right, because we have 0 here, we have 90 degrees there, and we have 180 there. It's 180 or 2 pi. Sorry, it's pi. 2 pi is going to go back again here. It's 2 pi, it's pi there. Then 165 is essentially the angle which takes you from the origin all the way back to the second quadrant. That's what we have done. And now, if you're at the second quadrant, all the purpose which we're going to do is that find some tricks, to find some strategies to end ourselves back to the first quadrant and somehow relate ourselves to triangles which we have learned about them, which we call them reference angles. Which were those angles? Can you tell them?
30, 45, 60.
That's right. These ones, they are golden angles. I call it golden angles in trigonometry because these angles, they are wherever you are going to be in this unit circle, mostly you can always get back to a combination of these angles and find, okay, how much is going to be the trigonometric ratio, and essentially evaluate and assess the behavior of these trigo functions. Because always remember, as a mathematicians, you know what is an angle, but you know what is 11 pi over 12. But when it's joined with the sine or any other ratios, it's gonna behave crazy. And now you are there to understand how crazy is that behavior and assess it, say, okay, what's gonna happen to this function? But 11 pi 12, as I said, it becomes 165. How did I get that? I put 1 over 80, sorry, 180, replace it by pi, becomes 11 times 180 divided by 12, it takes us to 165. Okay, and now my plan starts from here. I say, okay, 165 degrees, it's gonna be somewhere at the second quadrant. It means it's gonna be either from here to here. It's gonna end somewhere around here, but the point is at the circumference of the angle, at the circumference of the circle. But I know that, guys, that 165 becomes what? Becomes 45 plus 120. And now, at this stage, I'm going to always go back to find somewhere that I can also connect 120 to, let's say, reduce it back to any angles of the reference angle which I have now. Look at that. I'm just going to start from here. Then my strategy is to start from here. 120 it's going to be this. I know 45. 45 is a well-recognized golden angle in trigonometry. I know its sine, I know its cosine, I know all kind of trigonometric ratio. But 120 is still in the second quadrant. And this is not in the first quadrant and one of those my reference angles. And that's the problem. I have to just process it more to get to that. That's right. I'm going to do this. I'm going to write it here. I'm going to write it here. I'm going to say 120. $120, guys. Can I write it as 90 plus 30? Can I do that?
Yes.
Yes. And if I do that as 90 plus 30, and I see that, okay, I know about the 90 is a well-recognized angle. I know the sine, I know the cosine. But at the same time, I do not know what is 30. I know what is 30. 30 is a golden angle, which is one of the angles which we talked about that before, huh? It's going to be, for example, I know the sine, I know the cosine, whatever about the 30. It's a reference angle. So far, so good. Then you see that, guys, 11 pi divided by 12, it can be broken down first into 45 plus 120. Out of these two terms, which I have broken 165, 45 is a well-recognized. It's a Brad Pitt. It's the George Clooney. You know that. It's well-recognized. It's from Hollywood. Then you know about that. But 120, it's in the second quadrant. And now, then I said, okay, I'm going to decompose 120 into 90 plus 30, which it seems that now everything looks fine because 90 plus 30, I know about 90. 90 is going to be here. Everything is recognized about it. How much is the sine of the 90?
1.
1. How much is the cosine of the 90? Cosine, it means whatever x it gets. If you project it down, how much x does it have? 0, huh? Guys, that's a big problem here. Say something to me. How much is the cosine of the 90?
0.
Why?
Because cosine equal to x divided by r,
That's right.
and when x is at y-axis is equal to 0.
That's so true. That's so true, because when your point is at the y-axis, with the unit circle, the radius is 1. It means that y is 1, and the x is going to be 0 because the point is on the y-axis. When he defined the cosine ratio, which is going to be the x divided by the r, then it becomes 0 divided by the r. Then it becomes what? Then it becomes 0. That's right. And that's the thing that we know that here. Then 90 is a well-recognized angle, and 30, it's a reference angle that we talked about that before. We know whatever about this. Then you see, guys, from 165, I got to this stage that it's the sum of 45 plus 120. Then from the second stage, I got 90 plus 30. Then you see that 165 is composed of 3 angles, which is all recognized by me. 45, it's a reference angle. 90, we know it's an easy angle. We know everything about that because these are on the x and y axis. These points are very easy. And 30 degrees, that's one of those golden reference angle, which is 30, 45, 60. And it means that we got the key to a treasure. It's a gold map. This stage is very important to get there. Any questions, guys, so far?
No.
Thanks, Rose. How about Gloria, Ferris, and Philip?
No.
No.
Everything is fine with everyone? Awesome.
Yes.
If everything is fine, give me 1 second to grab a glass of water. I come back. I got thirsty. Okay, now we got to this point. And now what's going to be the next stage? The next stage is going to be this. Then I'm just going to say, okay, the new lesson, guys, starts from here. There is a proof behind it. I'm going to do the proof for you tomorrow. Oh, tomorrow is weekend, huh?
Yes.
I'm going to do the proof for you on Monday, but I give you the formula. We prove that on Monday. We are going to use it today a lot. Okay, now, at this stage, then I can write. Guys, please listen. Give me 1 second. Okay, now, at this stage, things are going to be getting very, very serious. Please listen. So far, it was a kind of a review, but from now on, things are going to get widely serious. Look at that. I'm just going to go back to the same thing. I'm going to go from here, which is my sine function. I'm going to start here. I say, I notice that the sine of 11 pi divided by 12 becomes, sine remains the same, but what we did was that we decomposed 165, which is 11 pi 12, into the sum of 3 angles. How many angles did we have? We had 45 plus and I'm going to write the other one in parentheses. For 120, I'm going to write it as 90 plus 30. I put it together. You see, please take extra care to see how am I doing it. It's very important. Then I say, okay, I keep the sign variable, it's that, and I have 45 plus 45, you get it from stage number 1, correct? Let me write it in stage number 1. Not with these ones. It seems that these markers all are dying. Stage 1. And this one was stage 2. And now look at this one, 45 from stage 1. Sorry. 45 is from stage 1. And 90 plus 30 is from stage 2. Then guys, look at that. What is spectacular here? I see the sum of two angles. I have a sine, and I have 45, and I have 90 plus 30. It's two angles. I can say that this is, for example, this one. Guys, listen very carefully. I call 45 and 90 plus 120 as two different angles. It's going to be, for example, my alpha, and it's going to be my beta. It's the sum of two angles. Then you see that when you just want to get the behavior of this angle when it is attacked by a sine function, you have two angles which is summed, which we haven't seen that before. Have you seen this before so far?
No.
No. Normally we had only one angle. For example, the thing which we did so far was, for example, like this. Look at that. The sine of one arc, the sine of one angle, which is attacked from behind by a trigonometric function. This person, 11 pi divided by 12, is attacked by sine. But here, it's one person which is attacked. It's like a fight. Look at that, guys, as a fight. Faris, are you there? Faris? How about Philip?
Yes.
Oh, you're there. Look at that. For example, that person, I call that Mr. Steve, for example, anyone, is being attacked in a fight by a sine function. But here, look at that. It's Steve and Jack. They are being attacked by another function, by sine function. And now the story is different. Before, they had a fight. One person was involved into a fight. But now we have a fight because of the sine is attacking someone, but we have two persons involved in a fight, alpha and beta. Clear so far?
Yes.
Yes? And now, how to win the fight? How to not to be beaten to death? How to win the fight? I'm going to give you one formula now. As I said, the proof is going to come on, I should say, next week. But now we do the proof right now. We say that if you have two functions, for example, it's going to be the sine of, it's going to have two angles, alpha plus beta. The proof comes next week, but now we use it and apply it because at function 11, the proof is less important than its application. Then what do? I say that if alpha is Mr. Smith, beta is I remember the movie Mr. and Mrs. Smith. Have you watched that? Angelina Jolie and Brad Pitt? They're going to go to a fight and they are being attacked by a sine. Now we have two fighters which are being attacked. And now we have this formula. It's going to be the sine alpha multiply to the cosine of beta plus. Now, the cosine of the alpha times the sine of the beta. That's the formula which we take it right now, but the proof comes on Monday. Okay, everyone can see what I've written?
Yes.
Yes, clearly, huh? Okay, let me highlight this identity. It's a very useful identity. Okay, now I get thirsty today a lot. And now look at this now. Then I have this formula. You can memorize it. Look at this. We have alpha and beta. They are fighting with sine. Then it becomes sine of alpha, cosine of beta. Because they are plus, they become plus. And now that's a term for the cosine alpha sine beta. You see that? Because this is sine, you start with the sine, and you add it by the cosine of the same angles. Previously, what did we have? We have the sine of 11 pi divided by 12 becomes the sine of these two angles. I'm going to rewrite this one here again. We had what? We had the sine of 11 pi 12 becomes the sine of 45 plus we had another angle, which it was what? Which it was 90 plus 30. Correct? And as you remember, I said that you can call this one 45. As alpha, and you look at the other one as beta. Correct? And now, everyone is okay so far? No questions?
Yes.
You have a question?
No.
Okay. And now, look at what's going to happen. I'm going to apply this formula into this and see what do I get. But remember, it's very important to recognize that you are in need to use this formula because remember, you have two angles which they are being attacked. Two angles not multiplied. Two angles which they are summed. If they were multiplied, you do not use this one. Only if they are summed or they are different, there is a difference between them. And I use this formula. If I use this formula, what do I get? The first one becomes sine of the alpha. What is my alpha here?
45.
That's right. It means that becomes the sine of 45 times cosine of beta. What is my beta?
90 plus 30.
That's so true. Plus the cosine of what?
Cosine 45.
Cosine of 45 times sine of what?
90 plus 30.
90 plus 30. Okay. And now we have this one, guys, so far. And now it seems that we are getting so close to the answers which we are looking for, which is these ones. That the sine of I should say it's 45, and the cosine of 45, they are the ratios that we know about them, correct?
Yes.
We know how much is sine of 45, we know how much is the cosine of 45, but there is one problem. Still, we have, look at this. Still, we have a problem. What is the problem? We have again two angles which they are being attacked, you see, by a sine and cosine function. You see that?
Yes.
That's right. Then as a result, I see these two terms, which they are troublesome. The first one is the cosine, which is attacking the sum of these two angles. And I have the sine, which is attacking again these two angles. Do you see that, guys? If I start from this one, because I have two angles, I use this formula to end up here. It seems much better right now. But because I know the sine of one angle and I know the cosine of the other angle, but the problem here is this, that I have the cosine and the sine of the sum of two angles, which there is the whole lesson to learn it right now. The first lesson is that I'm just going to use this one because I have the sine of, I call this one term 1, and I call this term 2, correct? I'm going to start by the term number 1. I'm going to come here and it starts from here. And I say term number 1. I have sine of 90 plus 30, correct? Which is essentially this second angle. You see that initially there were two angles, alpha and beta, they were summed, which they were attacked. And now when I use this formula, I do not have alpha anymore, and I now have the beta, which is 90 plus 30, which is being attacked again by the sine. And I can just go back to the same formula, right? Then how can I use this formula above? The sum of two angles which are being attacked by an outsider. Can you apply this formula?
It equals to sine 90 multiple cosine 30.
That's right, sine 90 multiplied to cosine 30 plus
cosine 90 and multiply sine 30.
sine 30, huh? Fantastic. Fantastic. Thanks. And now, do you look at this one? You see, guys, when you end up, still remember, I expanded term number 1, term number 2 is still untouched. I'm just looking at term number 1, which is the result of the second application of my master formula. I call it master. Hey, master, and that's my formula. Look at this one. When you look at the second time that you use this formula, you take a look back, you take a look at the right side. You see now, the fight is not fair because each person is fighting by an outsider, which is either sine or cosine. 90 is fighting with sine, 30 is fighting with cosine, and the fight is fair. Each person is being attacked by one person. And now, seems everything should be fine then. Now we can proceed to continue. For this one, sine of 90, how much is that?
1.
1. So true. Then I end up with only the cosine of how much? 30. Plus, Cosine of 90, how much is cosine of 90? We talked about that 2 minutes ago.
0.
0. Oh my God, I love this when it happens. Because when I have a cosine of one angle 0, it becomes very easy. And now I have 0 multiplied into the sine of 30 becomes how much?
0.
0. 0 being multiplied into anything, you get 0 at the end. Then you get 0 for the rest, and I'm not going to write it anymore. Then I have only cosine of 30. Then how much is cosine of 30?
Square root of 3 over 2.
Are you sure?
Yes.
Okay, awesome. Because for these ones, I honestly have to look back at my notes. How much did I use it from my special triangles? But in your test, I'm going to provide you these numbers for the special angles. Then guys, you see that term number 1, which was sine of 90 plus 30, ended up to the cosine of 30, which is the square root of 3 divided by 2. I'm going to go back to more explanation on that we see that the sine of 90 plus 30, it becomes a cosine of 30. We had something similar for the complement angle yesterday. Do you remember that? But it was 90 minus 30. That's right. Now we have something different. But still, it shows that having 90 converts the sine into the cosine, or cosine to the sine. We're going to talk more about that. And now I have this one. And now I go back to this because my first term, change it to the cosine of 30 because it becomes the square root of 3 divided by 2. But my problem, my original problem, which was sine of alpha plus beta, has a second term which is left, which is term 2. Term 2 is cosine of 90 plus 30. But before I just start with term number 2, do you have any questions so far? Someone who needs some explanation? Are you lost or you're doing okay?
No.
Thanks, Rose. How about the others? Gloria, Ferris, and Philip.
No.
No? How about Philip? And Ferris?
No.
Okay. Now what we have done, what time is it, guys? I have to be conscious of the time.
12.
It's 12, huh? Okay. We have only 10 minutes before the first break. Okay, now we should be done then. Okay, which page was that? It was page number 2. Okay, now I'm gonna do term number 2. You are gonna learn the second formula. Look at this one, guys. For the term number 2, you have the sum of two angles which are being attacked by a cosine. But the formula which I had for you here, it gave you when you have two persons being attacked by the sine, now we are being attacked by the cosine, which it means that I cannot use that formula anymore. And I have to provide a new formula. I'm going to write the formula for you. The proof comes on Monday. But we are going to use it now. What do we have is that I said as a formula that the cosine of the sum of angles alpha plus beta becomes what? Now it's a little bit different, and it's the most funniest part. Becomes cosine alpha cosine beta, which are multiplied. But now, guys, pay attention. It becomes minus. I put minus with a different color. This is plus. The angles are being summed. But this one becomes minus. Becomes the sine of alpha sine of beta. You see the cosines are shoulder by shoulder and the sines are shoulder by shoulder. This is going to be formula, master formula number 2. And as I said, the proof comes on Monday. Do not worry. The proof is very detailed, and we do the proof on Monday, but we take the result right now because we need to work with it. It becomes master formula number 2. Okay, now, where are we before? I read this formula in order to use that for term number 2. Term number 2 was what? I'm going to write it here. Term 2. Term number 2 in my main and original equation, where is my marker, was what? Was the cosine of 90 plus 30, correct? Then if I want to apply my master formula number 2, I'm going to put number 2 here, which shows that that's my master formula number 1. And I put 1 here, which shows that this is my master formula number 1. If I put these two angles here, what do I get at the end? Use this formula.
Cosine
Because you see two, that's right, becomes cosine
90 multiply cosine 30 minus sine 90 multiply sine 30.
Fantastic. Thanks, Rose. Sine 30. Now, guys, look at this. What a beautiful thing which we created. Now, I use master formula number 2 to end up with this. And now, what needs to be done? I just simply to take a look at the right side of my equation. Take a look at the right side. Right side, you see the game is now fair. Each person is being attacked by one outsider. I call trigonometric functions as an outsider which they attack, and these ones are becomes, for example, someone else. Everyone is being attacked by one, and now this is fair compared to the previous case that we had 2 persons being attacked by one. And now look at this one. Seems fair, and since we know every angle, because I know 90 and I know 30, 30 is my reference angle. And what happens here? It happens that I can write it here like that. What is cosine of 90?
0.
Oh, 0. I like it because it becomes 0. Multiply to cosine of 30 becomes 0. And minus sine 90. How much is sine 90?
1.
1. Multiply to sine 30. How much is sine 30?
1/2.
Are you sure, Rose?
Yes.
Awesome, thanks, because I have not my notes from previous session. Thanks. And now it becomes this. And now I see that 0 times sine cosine 3 becomes what? Becomes 0. Then you're only left with one number, minus 1/2. Right? Then you see here, we're going to talk more about that. Then the cosine of 90 plus 30, it ends up with the minus sine of 30. You see that with the complement angle, you have this one. We saw that before yesterday. Then now, guys, what happened? I find for term number 2, which is cosine 90 plus 30, I ended up with number minus 1/2, right? Any questions, guys, on it?
No.
No? Okay. And now, look at this. Where did we start? What was our original equation? Oh, my laptop battery is going to be finished. I have to finish it soon, then we go for the breakdown. The original problem we started with was this one, the sine of 2 angles. Then we ended up with this expansion by using this identity, that term 1, it become what? I'm going to write this once more. Look at this. It's my original equation. We had this one, we had sine of 45 divided by term number 1. How much is term number 1? We got this one here. Square root of 3 divided by 2, correct? Plus cosine of 45 times the sine of 90 plus 30, which it was cosine of, it was term 2. Term 2, it becomes this. Sorry, guys, I made a mistake. It becomes sine 45 times term number 1, term number 2, it was the cosine of 90 plus 30, which we ended up with what? Minus 1 over 2. And it's plus cosine of 45 times what? Term number 1, which is the sine of 90 plus 30. We ended up by what? This number, square root of 3 over 2. And now, what is sine of 45? It's a reference angle. We talked about that before.
Square root of 2 over 2.
Square root of 2 over 2 multiplied to minus 1 over 2 plus cosine of 45. The same thing, huh? Times square root of 3 over 2. Then from here, it becomes very easy to simplify that. You only multiply these things together, then you subtract this one from this. It becomes essentially at the end, you get what? You get 4 as a common denominator. You get the square root of 2 times the square root of 3 becomes 6 minus square root of 2. And that's the end result. It's going to be page number 3. Guys, I know that there were too many steps to deal with it. I hope that you got not too much confused, but I assure you that you're going to be a little confused. Everyone is fine now?
Yes.
Rose, did you got exactly what happened there?
Yes.
No question?
No.
Awesome. How about you, Philip? Philip? Gloria?
No.
Are you sure you have no question? You understood exactly what happened?
Yes.
Okay. How about you, Ferris? Ferris? They are not here. The boys are gone. Okay, guys. When we come back, I do more practices on this. I make sure that you learn it properly. Then in the meantime, please enjoy your break. What time is it now?
12:10.
12:10?
Yes.
Sharp on time. Please come back by 12:25 then. Okay?
Okay.
Awesome. See you soon then. Okay, guys, are you back? Hello?
Yes.
Everyone back now? Okay, let's move on and do something more fun. Okay. Now, before any questions, guys? Everyone is back. Please say your name if you're back.
Rose.
Philip.
And okay, let's continue. Okay, now the thing is that before I plan now before we end the session today, then we just be happy that we have the weekend ahead and there is no class tomorrow. I'm planning to just do work on two exercises or maybe three. Let's work with this one first. I'm just going to give you some exercises, then maximum three. Let's start with this one first. Let's deal with this function. Then I'm just going to ask you, please, to deal with this one. The cosine of 7 pi divided by 12. And look at that. Initially, it seems that this angle is being attacked by one outsider, and it seems to be a fair game. But let's see. I give you 1 minute to just investigate what's happening there with that example. Okay, how much is that angle in degrees then? It becomes 7 times 180 equals to this divided by 12. We get to 105 degrees. Guys, which quadrant is that angle is localized?
2.
Sorry, what?
Second.
That's right. The second quadrant, it's 105. Guys, are you done?
Not yet.
Not yet? Okay. Okay, let me do that. Are you done, Rose?
Yes.
Awesome. How about Philip, Gloria, and Ferris? Okay,
Not
let's
yet.
not yet. Okay, let me help me to finish this one. We do that together. Okay, guys, 7 pi divided by 12. How much degree was that?
105.
105. Okay. Then as soon as you look at that, you're looking at a trigonometric ratio analysis of an angle, which is essentially the cosine of 1 over 5. And 1 over 5, which is at the second quadrant, initially at the first look is not something apparent. It's not something which we have seen that before. Then our strategy and our goal is that to take it back to the first quadrant in our unit circle. But how to do that? But you have to think of it, how to just write that in terms of the angles, which is 30, 45, and 60. And that's the thing which I'm going to think into do that. If I write 60, if I write 105, can I write it in terms of 60 plus 45? Can I do that?
Yes.
Yes. Then if I do that, you will see that I have two angles, which is 60 and 45, which both of them are well recognized for me. I know how to deal with that. Okay. Then now essentially, the point which we're going to reach to is going to be this. We are going to go to here and say that the cosine of 7 pi divided by 12, it becomes what? Becomes the cosine of its decomposition. 7 pi divided by 12, which is 105 degrees, it's divided by 60 plus 45. How much 60 is in radians?
Uh, 60 of
Sorry, what?
pi divide pi over 3,
That's right. And how about 45?
pi over 2, pi over 4.
That's right. Thank you. Then now you see that, guys. We started with this animal here, 7 pi divided by 12. I decompose this one into two other arcs, which I know pi over 3, which is 60, is a well-recognized angle. And I know also pi over 4 also is a well-recognized angle. Both of them are the same thing. And now, what's going to be happening next is that I need to I see that the game is not fair. I have two persons, alpha and beta, which are being attacked by one outsider, which it seems to me I have to do what? I have to just use the formula, which we saw that a couple of minutes ago. What was this formula? We had this cosine of alpha plus beta equals to what? It's master equation number 2.
It equals cosine alpha multiply cosine beta minus sine alpha or multiply sine beta.
So true. Thank you, Rose. And now that's the identity, which I call that identity what? I call this one master equation 2. We had one with the sign. That's the equation which we had it before the break. And now I see that this equation, master equation number 2, it can be a roadmap for me for this one because I have alpha and beta attacked by an outsider, and that's the same story there. Then as a result, what is going to be the cosine of pi over 3 plus pi over 4? I'm going to follow term by term, which becomes what?
Cosine pi over 3 multiply cosine pi over 4.
Give me 1 second. Multiply to cosine pi over 4
minus sine pi over 3 multiplied sine pi over 4.
That's so true. Thank you, Rose. Pi over 4. And now, take a look there. Take a look at the right side, which is going to be this. The right side of this equation is this. You see that every term right now on the right side of my equation, after decomposing 7 pi divided by 12 to these two angles, is everything is recognized now. Pi over 3, pi over 4, they are well recognized angles then. Then I have to just go back to the chart, which we had. For the reference angles, I call them golden reference angles to see how much they are numerically evaluated at. Okay, in order to do that, what is cosine of pi over 3? Rose, do you have it on your paper?
Pi over 3 square root of 2 over 2.
No, pi over 3 cosine of
3.
pi over 3 becomes how much?
It's 1 over 2.
1 over 2 times cosine of pi over 2 becomes 5 over 2, square root of 2 divided by 2. And how about this one, sine pi over 3, Rose?
Pi over 3 is square root of 3 over 2.
That's right. Square root of 3 over 2. Multiply 2, again, the same thing, the square root of 2 divided by 2. Thanks, Rose. And the rest is going to be very easy. That's a simple algebraic, I should say, simplification. I can multiply 1 over 2 into each term, then take the numerator, take the common factor as 4, then becomes the square root of 2 minus 6. That's right. Becomes 2, square root of 2, 6, 4. Any questions, guys?
Is this 6 or square root of 6?
Oh, yeah, that's so true. Thanks, Rose. I didn't see that. The square root of 6. Thank you very much. Becomes the square root of 2 minus the square root of 6 divided by 4. Thanks a lot, Rose. I made a mistake. Okay. Which page is that? Page number 3, page number 4. Any questions, guys?
No.
Nothing?
No.
Okay, how about Gloria, Ferris, and Philip?
No.
No, everything is fine for everyone?
Yes.
Great. Okay, now let's go to one more example. Page number 4. Let's do this on the back. Just going to give you a very good example. Okay, I got something very interesting. Okay, let's do this one, guys. I have the cosine of this one, cosine of 12 degrees times cosine of 3 degrees minus sine 12 times sine 3 degrees. Guys, look at this example. The plan which we have is that we have an expression which has two terms, term 1 and term 2. We are going to end up with one single term and find the numerical value of it. We have cosine 12 times cosine 3 minus sine 12 sine 3. Give it a couple of minutes, try to see that if we can find only one term for this expanded, I should say, item. Okay, you understand what needs to be done?
Yes.
Awesome. Please give it a try. And please let me know when you're done. Okay, guys, are you done?
Yes.
Who said yes?
Rose.
Okay, fantastic. Okay, guys, look at that. This exercise, how much time did we have? I think we have almost over 15 minutes. That's totally fine. Guys, look at this one. I have two terms here, the first term and the second term. That's term number 1, and that's term number 2. Term number 1 and term number 2. Look at this. For this case, you see that you can find a quite resemblance, I should say, to this equation that we had, that we said that the cosine alpha cosine beta minus sine alpha sine beta should equal to the cosine of alpha plus beta. That's right. You see that a very interesting similarity to this equation, correct? And now, then as a result, when you look back to see that term number 1 can represent this one, cosine alpha cosine beta, and term number 2 represents sine alpha minus sine beta. Then you can very easily see that from this exercise that 12 can play the role of the alpha, 3 can play the role of the beta, correct? Then as a result, You come to say, okay, this one then this, the whole expression, is such a vast expanded expression, can be simplified into only one term. And that term is going to be cosine of what? 12 plus 3. Because we have cosine of alpha plus beta, then I have cosine of 12 plus 3, which equals to what? Cosine of
15.
15. This is only one term. You see that the whole expanded term, it's only represented by one single cosine term of only one angle. So far, so good, guys?
Yes.
Any questions on that?
No.
No? How about Philip, Ferris, and Gloria?
No.
Awesome. But guys, look at that. Should I continue further? What is cosine 15? How much is that?
Is square root of 6 plus square root 2 over 4.
Square root of 6? Say it again, please.
Square root of 6 plus square root of 2 over 4.
That's right. That's right. How did you get that, Rose?
I calculate
How?
on my calculator.
Okay, no worries. Look at that. Then how is that going to be? How can we proceed further? I can just write this expression like this. How about if I write 15 as 60 minus 45? Can I write it like that?
Yes.
That's right. And I see that these 16 and 45, they are very well recognized angles. I know 60 and 45, they are my golden reference angles in trigonometry. Then now, it means that in order to continue further, I can simply come here and I say, okay, from this stage, I can come here and I say, I'm going to write cosine of 50 equals to the cosine of pi over 60 minus 45, correct? That's what you're here. And guys, you see that again, you have two angles which are being attacked by one outsider, but the problem is that the previous formula which we learned here, it shows that if two angles are summed, we can use this formula. Let me show you my master equation number 2. Look, my master equation number 2, which we had it before. We said that the cosine of the sum of two angles becomes what? Becomes the cosine product minus the sine product. This is plus, this is minus. But now here, guys, the story is different. The story is that I have the difference of these two angles. Then what needs to be done? I'm just going to introduce you to another, I should say, identity, which we're going to have the proof of all of them on Monday that we are fresh. As here, I'm just going to write this identity. We said that the cosine of alpha minus beta. Previously, on master equation number 2, we had the cosine of the sum of those angles. And now I have the cosine of a difference of those angles, which becomes, it follows the same pattern. I write cosine alpha, cosine beta, but because I have for cosine only, I have minus in between, I change it to the plus. And I get what? I get sine alpha, sine beta. It becomes what? It becomes my master equation number 3. call this master equation. Number 3. Okay. Any questions, guys, on it? We proved that on Monday, but we're going to use it now. It shows that if the cosine of two angles, which they are not summed as equation number 2, they are different. And now because this is minus there, I put it plus here. Okay? And now, if I'm going to use this, I come to the next page. And what do I have here? I have the cosine of 50. I was interested into doing this, which I learned that it becomes cosine of 60 minus 45. And now, what can I do here? We saw that identity before, that the cosine of alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. I have the same problem here, the same story here. It's going to be very easy now that I plug in only values there. Then the cosine of 60, let's write 60 as pi over 3 minus pi over 4 for, I should say, for 45 degrees. Then how much is that going to be? Use the formula for it.
Is it cosine or sine?
This is cosine of pi.
Oh, cosine pi over 3 multiply cosine pi over 4
That's right.
and minus sine
And
pi.
you plus. Because Rose, if the angles are different between them, they becomes plus here. If they are plus, they becomes minus.
Plus sine pi over 3 and multiply sine pi over minus plus pi over 4.
That's right. Thank you. And now we take a look at the right side. We see that now the game is now fair. We do not have two different angles which are being attacked by an outsider, but we have angles which every angle is attacked by an outsider. And I know everything about these angles. What is cosine of pi over 3?
One over 2.
I have 1 over 2. Cosine of the pi over 4 becomes square root of 2 over 2, correct?
Yes.
Plus, how about sine of pi over 3, Rose?
Square root 3 over 2.
Times the sine of pi over 4 becomes the square root of 2 over 2. And now, things are getting extremely easy because now this is only the matter of algebraic manipulation. I have, for this term, I have the square root of 2 divided by 4. From the second term, I have what? I have the square root of 6 divided by 4, which the end result becomes how much? I have the 4 as a common denominator. I have the square root of 2 plus square root of 6. Did you get the same answer, Rose, initially?
Yes.
Fantastic. You're very much smarter, and you said it at the beginning then. Okay, guys, you see that by using this identity, I was able to understand what is the cosine of the 15, which initially it seems that's so hard to find it, but I just was able to convert that into, I should say, 2 reference angles and find the value of it. Correct? Makes sense?
Yes.
Awesome. Any questions?
No.
Everything is fine?
Yes.
How about for Gloria and Ferris?
No.
You're fine, Gloria? No questions?
Yes.
Thank you. How about you, Ferris? 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 No one? Okay. Guys, we finished the session today here, and I'm just going to give you some homework. It's a comprehensive homework. There's lots of questions for it. And you can also, I should say, look into that and finish it by the end of the weekend. I'm going to post the homework today before the end of the day. And you have Saturday and Sunday to work on those homeworks. And please, if you have any questions, post your questions on the Schoology website. Okay?
Okay.
Awesome. Then, guys, I see you on Monday, and I hope that you have a nice weekend then.
Goodbye.
Thanks. Bye, Rose. Bye, Gloria. Bye, Ferry.
Bye.
Bye. Bye, everyone. Bye, Rose.
Bye.
See you later.